Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of oblique asymptotes. So as per the problem, determine the equation of oblique asymptote for each of the following and determine the direction from which the curve approaches the asymptote. So let's start with the first function. So f at x equals x cubed minus 1 over x squared plus 2x. So this is a rational function. Now we can get the equation of the oblique asymptote for this function by doing the polynomial division. So we can use long division method for this problem. So let's start with the setup. So the expression in the numerator is called the dividend and the expression in the denominator is called the divisor. So we'll do the setup for long division. So we start with the dividend. Now in this dividend, the x square and the x terms are missing. So to make the long division process easier, we'll introduce the x square and x terms in this expression as 0x squared plus 0x minus 1. So these terms 0x square and 0x do not change the dividend, but it just becomes easier to do the polynomial long division. And then we use this symbol for long division, and then we write the divisor on the left side. So x squared plus 2x. So in the first step, we have to get rid of the x cube in the dividend. So we'll divide this x cube by the first term in the divisor x squared to get the first term in the quotient. So x cube over x squared is equal to x. So that's the first term in the quotient. So now we'll multiply the divisor by x. So x squared times x is x cubed and 2x times x is 2x squared. Now we can subtract the terms. So the x cubed terms get cancelled out and 0 minus 2x squared is negative 2x squared. Now we can bring the 0x down. Now we have to get rid of negative 2x squared. So we'll divide negative 2x squared by the first term in the divisor, which is x squared, which gives us negative 2. So that's the second term in the quotient. So now we'll multiply negative 2 by the divisor. So negative 2 times x squared is negative 2x squared. And negative 2 times positive 2x is negative 4x. Now we can subtract the terms. So negative 2x squared gets cancelled out. And 0x minus negative 4x is positive 4x. And now we can move the negative 1 down. Now 4x minus 1 has a degree which is less than the degree of the divisor. So the degree of the divisor is 2, but the degree of 4x minus 1 is 1. So that means this is the end of this polynomial long division. So the equation of the oblique asymptote is the quotient of this long division. So the oblique asymptote so this can be written as y equals x minus 2. So this function f at x can be rewritten as f at x equals so x minus 2 plus then 4x minus 1 over x squared plus 2x. Now to answer the second part, which is determine the direction from which the curve approaches the asymptote, we'll have to analyze this fraction. So if this fraction has a value greater than 0, that means the curve approaches the asymptote from above. But if this fraction has a value less than 0, that means the curve approaches the asymptote from below. So now we can do the limit calculation. So limit x approaches -100. So we have to use a number on the left side of the x-axis. So 4x minus 1 over x squared plus 2x. So now we can apply the limit. So 4 times -100 minus 1 over -100 square plus 2 times -100. So now we can simplify this expression. So 4 times -100 is -400 and minus 1 is -401 over, now in the denominator, -100 square is equal to 10,000 and then 2 times -100 is -200. So 10,000 minus 200 will be 9,800. So we will end up with a negative value. So that means on the left side, so curve approaches the asymptote from below. Curve Now we can do the analysis for the x value on the right side of the x-axis. So we'll apply the limit x approaches positive 100 for 4x minus 1 over x squared plus x. So now we can apply the limit. So we get 4 times 100 minus 1 over 100 squared plus 2 times 100. So in the numerator, we'll get a positive value, and in the denominator, we'll get a positive value. That means the overall value will be positive. So that means the curve will approach the asymptote from above. So this should be the final answer for the first function. So now we can analyze the second function. Now again, we'll have to start with the polynomial long division to find the equation of the oblique asymptote, which will be the quotient of the long division. So the numerator expression is the dividend and the denominator is the divisor. So we'll start x squared minus 4x plus 3. So that's the divisor. And then x cubed minus x squared minus 9x plus 15. So first we have to get rid of the x cube. So we'll divide x cube by the first term in the divisor, which is x squared. So x cubed over x squared equals x. So that's the first term in the quotient. Now we'll multiply the divisor by x. So we'll get x cubed minus 4x squared and then plus 3x. Now we can subtract the terms. So the x cubes get cancelled out. So minus x squared minus 4x squared will be 3x squared. and then minus 9x minus 3x will be negative 12x. And now we can bring down the 15. Now we have to get rid of 3x squared. So we'll divide 3x squared by the first term in the divisor, which is x squared, to get the second term in the quotient, which is equal to 3. So plus 3. So now we'll multiply the divisor by 3. So we get 3x squared minus 12x and then plus 9. Now we can subtract the terms. So 3x squares get cancelled out. Now in this case, the negative 12x and the negative 12x also get cancelled out because we are subtracting them. And 15 minus 9 is 6. So that's the remainder of this long division. So in this case, the equation of the oblique asymptote is y equals x plus 3. Now we can rewrite this function as fx equals x plus 3 plus 6 over the divisor x squared minus 4x plus 3. Now we have to analyze this fraction to find out whether the curve approaches the asymptote from above or below. So if this fraction has a positive value, that means the curve approaches from above. If it has a negative value, that means it approaches from below. So we'll do the limit test for the left side and the right side of the x-axis. So let's start with the test on the left side. So we'll use the limit x approaches a big negative number like negative 1 and then 6 over x squared minus 4x plus 3. Now we can apply the limit. So 6 over negative 100 squared minus 4 times negative 100 and then plus 3. So now in this case, the numerator will always be positive because it's just a positive number 6. And in the denominator, we'll end up with a positive value because negative 100 square is 10,000 and then negative 4 times negative 100 is positive 400 and then plus 3. So we'll end up with a positive value. So the overall value for this limit will be positive. So that means on the left side of the x-axis, the curve approaches the asymptote from above. So we can write the conclusion. So curve approaches from above. Now we can analyze on the right side of the x-axis. So for that we'll use a big positive number. Limit x approaches 100. So 6 over x squared minus 4x plus 3. Now we can apply the limit. So we get 6 over 100 squared minus 4 times 100 plus 3. So we'll end up with a positive value in the numerator, and in the denominator 100 square is 10,000 minus 4 times 100 is 400 plus 3. So we'll end up with a positive in the denominator as well. So the overall value for this limit will be positive. That means the curve approaches the asymptote from above. So this should be the final answer for this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.